Hey guys, today we're going to be talking about arithmetic sequences or arithmetic sequences. And so it's going to feel like we're kind of like taking a step away from what we've been doing with domain and range and functions. But what we're going to do is we're going to see how to create an equation from a sequence using a specific formula. And then we're going to change that to look more like a function so you can see how it kind of fits into this unit. So first off, I want you to look at this set of numbers right here. And before I'm doing anything, I want you to just think about the pattern that you see. We're going to revisit that in just a moment. So a sequence is a set of numbers that follows a specific order or pattern like the one before. Sequences typically begin with the first or an initial term and either increase or decrease at a constant rate from that initial term. Sequences are functions. In other words, you wouldn't have a sequence of numbers and go 1, 2, 3, 3, 3, 4. They do not start at the y-axis. Therefore, they do not have a y-intercept. In other words, if you're counting a sequence of numbers, you don't start at 0, you start at 1. 1, 2, 3, 4, 5, or whatever the difference is, but you don't start counting at 0. The position of the sequence is represented by the letter 1. This is where the results are located within the sequence. The sequence typically begins with this first term, and that's indicated by n is 1. And you'll see what that means a little bit more later. It'll make a lot more sense in just a little bit. The value of the sequence represents the change from one term to the next. So you might have whatever number is in the first position has a value to it. Maybe it's 2. The number that's in the second position might have the value of 4. The number in the third position might have the value of 6. The arithmetic sequence is a sequence that goes from one term to the other next by always adding or subtracting. The constant amount that we're adding or subtracting is called the common difference. And I know when you see the word difference, you think that you're subtracting, and you are. But think about, again, the pattern 2, 4, 6, 8, 10. The difference between the 2 and the 4, whether you're going up by 2s or backwards by 2s, is 2. And so it's the difference between the two numbers. Now, we're going to go back to this previous sequence. And what was the common difference that you noticed? The common difference was 3. And so I'm going to kind of put some things here that might help a little bit, some of the things that we've been talking about. So if I said 4 is the value, then it is also in the first position. The 7 is the value in the second position. 10 is the value in the third position. 13 is the value in the fourth position. 16 is the value in the fifth position. And because we know these things, we know what the common difference is, we know what the first term is, we can determine other terms that are farther out. We can use that common difference to find the next 4 terms. So 16 would be 19, 22, 25, 28. I just added 3 to each one of those. So let's look at this next one here. The common difference here would be 15 to 9. The common difference is a -6 or -6. And from here again, we could figure out the next terms by simply going, okay, if we're at -3 and I subtract 6, I get a -9. If I have a -9 and I subtract 6, I get a -15. If I have a -15 and I subtract 6, I get a -21. And then from there, I would have a -27. The next one here, the common difference is 1.5. And again, we could work our way out from this, and I would get 15.5, 17, 18.5, and 20. So again, you can see once you know the common difference and you know a term, you can always know the next term. All right, now we look at this weird formula that you probably won't appreciate that much, but there's really just two things that you need to focus on. There's the common difference we talked about, and there is the first, well, it could be any term, but mostly you want to pay attention to the first term. This you will always see written. It's just telling you that n has to be a number greater than, it can be 2 or greater than 2. It's just a notation. You'll see it written alongside all of these. You can kind of ignore it. So again, this means a subscript n means the value of the next term. A subscript n minus 1 is the value of the previous term. So we're always going back one. So in order for me, if I know that I'm going up by 3s, and then I'm at 5, I know that the previous term is 2. The first term of the sequence is represented by this. And this is something you want to remember what that means. When you say a subscript 1, that's not an exponent. It's just saying the first number in the arithmetic sequence, the A arithmetic sequence, the first number. So let's look here. They tell us that the first number is 7 and that the common difference is 12. So that would mean that I'm going to add a negative 12. And so I get a negative 5. Now I don't actually have to say add a negative. You can see that this is the formula. But if you're adding a negative, you can actually just say minus. So I'm going to do that on the next one. I just figured out that because I know what a sub 1 was 7, I figured out the next number was a subscript 2. And so I'm going to add a negative to that one. And then a subscript 3 is negative 17, and I'm going to add a negative 12 to that. And I can keep going, and you can see we can just keep going and going as however far we're supposed to go. The values such as a subscript n and a subscript n minus 1 can be changed so the arithmetic sequence looks like a function. So here we go back to functions again, and we're going to close with this. So instead of it looking, let me come back up here. We're going to look at this, and I want you to compare it to this. It looks pretty much the same, right? So f of n, and you can see f of n minus 1 plus d. It's pretty much the same thing. It looks a little bit different. Just know that it's the same thing and nothing really changes. So again, I can look at that, and I can look at this set of numbers here, and I can tell that the first term this is the first term in the sequence, number 1 is 13. And I can look and see that the common difference between from 13 to 4 is a negative 9. So when I write this rule right here, I'm going to write f of n such that f of n minus 1 minus 9. And then we always, always, always state what the first term is, because we need the first term to find the next term. So we'll always state that. And then this next one here, it tells you again the first term, and then it tells you the difference. Those are the things that you'll look for. And they want to know, well, what would be the next terms? Well, we know that, well, actually asks the first 4 terms. So there's the first term, 6. I'm going to add 2.5, and then that means I will get an 8.5. And then I'm going to add 2.5 again, and I'm going to get 11. And then I'm going to add 2.5 again, and I'm going to get 13.5. So this would be more the expectation of you would be to look at something like this and be able to deduce that. Or to look at something like this and be able to tell me what is the first term, and what is the common difference. So don't get too caught up in the actual formula and having to write the formula, because you won't actually have to write the formula. You'll just have to be able to look at a formula and understand what two of the numbers represent in that formula and a sequence of numbers you can get from that formula. Okay, now you're going to be on your own with the practice. Good luck, and always ask questions when you need to. See you later.